Boss, good evening. Can you hear me, boss? I'm actually outside though, so I'm just trying to.
Hello.
Yeah, bro, how you doing today?
Yeah, I'm very well, okay. How far
Yeah,
now?
I'm all
I'm
right.
waiting
Bro.
for others to join.
So I'm actually
But it's
outside,
cool.
but yeah, I'm actually
Okay,
outside, but I'll try to ensure that I take
it's
record
fine.
of
I'll
lecture.
still wait. We saw one person to have joined. It's fine. So there's going to be recording for the classes, right? So if you miss out any parts, you can always watch the video
Okay, that's
to
fine.
get
That's
the concepts or the topics that we mixed, right?
okay. That's good. Thank you.
So it's fine. I would wait to, let's say, 5 more minutes to
Okay.
see whoever that will join again and start. All right. Welcome, Adibola.
Thank you, sir. Good evening.
Good evening. It's good to have you here. How's the weekend
Thank you.
going now?
Good fine, sir.
Yeah.
Okay, we're waiting for remaining one person.
Yeah, we'll be starting shortly. Let's just wait
Okay,
for
sir.
3 more minutes.
All right.
Yeah, pass. It's this guys.
Yeah, good night, man.
Outside, go to the good night. All right, now. Get your class.
Okay, good night.
Okay. Hello. Hello. Can you all hear me?
Yes, I can hear you.
Okay. Good evening, everybody.
Good evening, sir.
Yeah.
Good
Good
evening,
evening.
sir.
Hi. Hi. Good evening. What's up? How's everybody doing now? Happy weekend once
Good evening,
again.
sir. I'm fine. Oh,
Good
happy
evening.
weekend.
So, please confirm if you can see my screen.
Yes, sir. We can see your screen.
Okay.
Yes, good evening.
So we are going to be starting with. Okay. Let me do this. Let me. It's okay. Okay. You can see my screen now, right?
Yes, yes, we can see your screen.
Okay. So, sorry, please. How many of us? Can you please identify if you are just hearing CCNA for the first time, or if you have experience with the CCNA skill set, or probably you've heard of it, but you don't really know what it's about.
Yeah, yes, sure. Yes, I've heard of it, but I don't really know how it works.
Okay. So CCNA is an acronym, just an abbreviation for Cisco Certified Network Associate. Cisco is the biggest name in computer networking and security, and having the CCNA certification verifies that you have the skill set to, support, manage, and secure enterprise networks. And it's the foundational certification that you need to have to embark in the cybersecurity career if you want to go into cybersecurity. So CCNA helps you to have, it gives you the skill sets. It enables you to have the skill sets of supporting users, supporting networks, managing networks, securing networks, and even advancing your career in cybersecurity if you wish to. Right. So this is the module 1 of CCNA. If you see, I don't know if you are seeing the agenda for this training. There are 3 major topics that are there. They're actually modules. So introduction to networks, switching, routing, and wireless essentials, then enterprise networking, security, and automation. So basically, the introduction to network is the first module, which is what we are going to be starting with tonight. The first module, which is the introduction to network, has 16 chapters, right? Then the second module, which is switching, routing, and wireless essentials, has 16 chapters as well. And the third one has about, which is the enterprise networking and security automation. It has roughly 14 chapters. So this CCNA is loaded, right? So the reason why you have many of these topics combined into one CCNA is because before now, there used to be CCNA for routing and switching. There also used to be CCNA for voice. That's the intercom configuration, talking of telecoms using voice. There was also a CCNA certification for security. And yes, there was also CCNA certification for wireless. So all these security, routing and switching, scaling net, so everything was combined together now. Currently, it's combined together into one. And that's why we are having, so as at the time I did my own CCNA, it was version 6. So currently, the CCNA is now version 7. Right? It has all the routing and switching. Those people, in fact, there were some people who had about 5 CCNAs back then. They had CCNA for wireless, CCNA for voice, CCNA for routing and switching, then CCNA for security. Do you understand? So all these CCNA certifications were combined together to form this version of CCNA that you guys want to try. Right? So it is loaded. You have a lot of topics covered in this particular training. So stay tuned. Um, you can see my slides, right?
Yes, sir.
Okay, so talking of networking today, if you look at the material I shared with you guys, the first topic there that we have is okay, under introduction to network modules, you can see. So the first topic is networking today, chapter 1. Did you guys download the material? Were you able to download the materials?
You mean the software
Hello?
or the yes?
I shared both the software and the materials with you guys.
Yes, we have the materials.
And you saw the official guide, this PDF that I'm opening right now, that you're seeing on the screen.
Yes. It's there.
Okay, so I will not be using this PDF. I just want you to know I have the instructor slides that we're using, right? So this is just detailing what we have in the instructor guide, the instructor slides rather, that I'm using to walk you guys through the course. Okay, so take your time to read through and let me know if you're having any issues. Okay, talking of networking today, right? What is networking to be precise? Do you have any idea? Who has an idea what computer networking is about? Okay, I don't want to waste most of our time. Let's dive into um the topic of today. Then I will explain it in the later modules. So the objective of this particular chapter is called, as you can see, is to understand how computer networking affects our lives. Then we are going to be talking about the network components as well, the components that makes up the network. We have the host and the intermediary devices, which is the likes of the switches, the routers, the firewalls, and other devices as well. Then we'll be looking at the network representation and topologies, right? The physical and logical topologies, we'll look at that. So we're looking at the common type of networks as well, the types of networks that we have and what makes them different, right? So we're going to be talking about internet connections as well. We'll talk about why, okay, the components that every network should have before you can consider it a reliable network. We'll look at network trends as well. Here is my, let me go into full screen. Sorry, I'm trying to bring out my Epic pen. Okay. So we are going to look at network trends. What are the new trends in computer networking and how we can adopt them to our current, our existing networks, right? Then we are going to be talking about network security as well. And what makes you an IT professional. Let me select the right. Hold on. I think this is fine. Okay. So talking about how network affects our lives. Now we all know that communication is important, not just in relationship, but in our day-to-day life, right? So just as we rely on air, water, food, and shelter in today's world, we also rely on communication. Communication is very, very important. Now, before now, there used to be IT, right? When you see IT, talking of information technology, there was no communication technology. There was no CT, right, before now. So IT, in the sense that everything only exists within a geographical location, right? So data transfer was never possible. The only way data transfer was done was to move data into storage devices. Back then, I don't know if you guys know of diskettes. Diskettes was the first um, storage media that was used back then. Then later on, the idea of having a DVD or CD came up. Then later we started using pen drives, the popularly known as flash drives now. So back then they would copy files or data into diskettes. Then the person is going to travel. Imagine you're here in Lagos and you want to send a data to somebody in Abuja, for instance. So you copy the data into your diskette, you hand it over to a courier service. Was there even courier service then? So you take it to the post office, yeah. Then they will post this ticket and they will post it down to the person in Abuja. So the person is going to receive it. You can see how long it's going to take. So it's not like they post it immediately. It takes a couple of days most times, right? So most times they take those things in batches. They can't take only your item to Abuja. Most times they wait to accumulate those things together till they help to a certain amount before moving it over. So it takes days, right? And besides, there are even limits to the kind of data. So during transit, anything is likely to happen to that particular diskette. So it can be stolen from the person that is moving it down to Abuja, and it can even get damaged while on transit. So most times it was not always easy. So but with the birth of communication in IT, everything now seems to be possible within not just a geographical area, but within the world, like all round. You can communicate, there's no more boundary to the kind of thing you can do. There are no limitations again. Files can be shared across within limits, you know, irrespective of your location, you can reach out to whoever it is you want to reach out to. And also within just few clicks, files can now be shared. See the way I shared the networking material with you guys, right? I just uploaded it to my OneDrive. I created a link for it and shared it with you guys. So if you happen to be in UK, the same way you downloaded it is the way you download it. If you happen, even if you like, just be anywhere. So long as you have internet access, you can access the file that is shared with you through that link. So that's one of the advantage of networking today. It makes communication easier, right? So okay, so this is talking about Networking Academy. Cisco Networking Academy is a learning platform that teaches you how to use the Cisco technologies, not just Cisco technology, but other technologies as well, right? So towards the end of this training, I'll be sharing a link with you guys that you sign up with on the Cisco Networking Academy to take all the chapter quizzes that are relating to the modules that we've covered so far from the beginning of this course till the end, right? So just know that Cisco Networking Academy, let me show you. I think I have this. This is Cisco Networking Academy. This is the new UI, right? They have the old UI that I'm very much used to. This is how it is. So you can sign in with your credentials. If you have your credentials, you can sign in with it and you're in. So for now, they still left the old UI. You can see these are some of the modules I've done. So because I did CCNA version 6, so I had to do the bridge course. Bridge course, what this course actually taught me was, it was designed to, cover the topics that were not covered in version 6 that I did. Do you understand? So because they added new topics to version 7 that you guys are doing now, that we did not cover during our version 6. So the way they shuffled the course, some of the topics I did during my version 6, they moved it over to CMP, which is more advanced, and brought in new topics. So they did this bridge course. Instead of you taking the whole CCNA again, they did this bridging course for we that did version 6. So as to cover those topics that were not covered during our own time. So this is how the Cisco Networking Academy is. You can come to your resources here. You can see this is why I downloaded the Cisco Packet Tracer from. It's actually free. You come down here and see this is for Windows and this is for Ubuntu. And this is for Mac. This is the one I shared with what's that his name? Yeah. Yes. So this is where I got them from. We have the 64 and 32 bits, right? Depending on the kind of system you're using. So at the end of this module, by the time I share the link to this portal, the reason I'm not sharing it now is because if I share it with you now, you'll have a timeline. to finish up. And I know you're not going to meet up with the timeline, so I'm just taking my time. So by the time we cover the other topics, I'll share them with you. You do all the chapter quizzes, and if at the end of the chapter quizzes your score is over 75%, Cisco is going to give you a discount to write your exam. I got a couple of discounts. I remember I got a couple of them. Let me just see if I have them here. You can see this was in 2020, this was in 2020 as well, 2020, 2021. Look at these ones too. Imagine currently CCNA is $300. So imagine if you are getting 61% off. It depends. If you are lucky, they will give you 70%. If you are lucky, they'll give. Look at this. This was 36%. So it depends. So it depends on your luck. So most times, what they do is they give people 59% currently now. Currently, what I've been hearing a lot of people say is they give them 59%. So out of $300, instead of paying $300 around 400 something thousand now. So you just pay about $21.50 or something to go write the exam. Right. So if they give you the discount, you have a validity period of 6 months to use it. And see all these ones that expired. I didn't use them because there was nobody to give. Right. So all the people within my circle have already taken the exams. That's why I had to just be able to expire. So when they give you, you can see they gave me April and it expired in July. So you have just 6 months validity. So you have to be very prepared before you can finish up. That's why I want to take my time for us to walk through the course. Then you can now embark on taking the modules to get the discounts. So talking of, okay, let's come to this. Now, talking about networking today, like I said, there are no boundaries anymore like it used to be when it was just information technology. Now it is ICT. Before it was IT, just information technology. Now it is information communication technology. Communication can be between anybody at anywhere in any time. Right. So the communities, we don't have global communities, people can network irrespective of their locations. Right. So now talking of network components, what are the components that makes up a network? There are a lot of them. So let's see. We'll be starting with hosts. What's a host on a network? See what they said here, that the host is a computer on a network that is every computer on a network is called a host. So this name host and end device is usually used interchangeably. But a lot of people get confused with it most times. Right. So the thing is, this host is a generic term for all the devices on a network. Do you understand? So this end device, they're talking about, when you say end device, you're talking about how like a device that is using the service of the network. It can be a PC. A PC can be a tab, can be, when I say a PC, I mean either a desktop or a laptop. Right? It can be a tab, can be a phone, like that. So they're also referred to as clients. Because the kind of architecture we have today in computer networking is a client-server architecture. Client-server kind of architecture. So a server is a device that provides resources on the network. So a client usually initiates the need the services of a server. So most times, for instance, you're having a web server, for instance. If I open facebook.com, there's a server on the internet hosting Facebook websites, right? So when I say facebook.com, when I say facebook.com and I type it in my URL, you can see it brings me down to this place. If I click on it, there's a request that is sent from my PC. My PC is a client in this scenario now. The server hosting the Facebook website is a server. Let me not say the device hosting the Facebook website is a server. My PC in this case is a client. So I need to access a web page on that server. So when I click on it, it sends an HTTP request to the server, and the server replies me, and the page will load on my browser here. Do you get it? So that's what happens in this case. This is an internet. You're in your house. This person is in his house. For instance, in his house. This is the internet. This is Facebook. So the internet is maybe you're using probably you're using your MTN model here, connected to the internet. These guys are using an ISP that also connected to the internet. So ISPs can reach themselves and it's trying to open a web page. So when it sends the HTTP guest, it sends the get message, it gets down to the server responds to the web page and it displays on the user screen. That's why you're able to see most of the web pages you are seeing online today. So this is a client. A client is not a server, and a server is not a client. Do you understand? So there can be many kinds of servers online. I was just using this web scenario as an example. We can have an email server, we can have a DHCP server, we can have a file server, we can different kind of servers, depending on what you want. So all these servers have a services running on them. They have a service. Some servers can have several services running on them, one server. Yes, that's the kind of technology we use today. We have one server, we have several VMs running on them, virtual machines, and each virtual machine is running a particular service. Right? So that's how it is. So every computer on the network is referred to as a host or an end device, rather. So servers are computers that provide information to end devices. Like I said earlier, these guys provide services to the clients on the network. Right. So clients are they are computers that send requests to servers to retrieve information from them. It can be a web page, it can be an email, it can be whatever. So most times on your system, when you're accessing your Gmail, there is a computer on the internet that is hosting the Gmail service. It is called a server on the internet. You are having your own browser. Through your browser, you can access the client page that would request for your emails to be downloaded to your system. So you're using the client part to send requests to the server to see your emails that are dropping. Please let me know if you're not getting me. Are you all getting the statements right?
Yeah.
Okay, so that's how it is for these emails. You know, the email server runs the email server software. So when you say servers, servers can be in two forms. They can be in hardware and they can be in software. So when they say a server, I don't want to go in detail because we are still pretty much in the early phase of the course. So by the time we get, you know, to the advanced part, you get to understand it better. So, but just know that a server is a device that provides services to clients. That's just how it is. That's this, I think, the simplest term I can use. So it can now be the kind of services you now providing now it differs. It can be a web, can be an email server, can be file server, can be DHCP server, it can be a SaaS server, depending it's hosting the software online. Do you understand? So that's how it is. So talking of peer-to-peer components, we just talked about the client and server kind of architecture. This is the most common one on the internet, client and server. So peer-to-peer is also common, but a lot of people don't really know about it like that. So in this peer-to-peer kind of network, there is no server. There's no dedicated server running a particular service. So in this kind of network, you can be my server and I can be your server as well. Right? Look at this scenario, for instance. In this scenario, see, sorry. In this scenario, these guys are connected to each other. Then this guy is in turn connecting to this printer. Now, this guy has a file to share. This guy has a printer to share. So if you look at it in this case now, let's say this is PCA, for instance, and this is PCB. So PCA wants to access a file in PCB. The file is residing on PCB and PCA wants to access the file. So in this case now, PCB is a file server. Is a file server. Do you understand? Because it's hosting the particular file that PCA needs to access. Then, on the other hand, PCA has access to this printer here. Let's say host C. PCA has access to it. PCB wants to print, but because it's not connecting directly to the printer, it cannot print. The only way it can print is if PCA that is connecting directly to the printer shares its printing service with it. The printer is only configured on PCA. So not until the PCA shares its printing service with this guy will not be able to print. So in this case now, PCB can be considered a print server, because it's the one providing the print services to PCB. So if PCA should be down, PCB will not be able to print, because it's the one connecting directly to the printer. I don't know if I'm making any sense. So in a peer-to-peer network, you can be my server and I can be your server as well, depending on the use case. Okay, another clear example that I can use is this Zender software that almost everybody have on our Android phones. Take for instance, I have some movies on my system, on my phone, and I want to share the movies with you. So in that case, my phone is the server and your phone is the client, because I have movies on my, so you are getting the movies from my phone, right? So you are connecting to me as a client. I am the server. That's how it is. So if you also have a file on your own phone that I want to access, I'll connect to you as a client and you are the server. So in a peer-to-peer network, there's no dedicated server that is providing services to anybody. So a client can be providing a service to another client. And in that case, the client is the server to that particular client at that time. So once that service is done, then it's no more the server. So once it's done rendering that particular service, it is no more the server. So what they are saying here is it is possible to have a device to be a client and a server in a peer-to-peer network. So the device can be a client and it can be a server at the same time, depending on the use case. So, but it is not a scalable design, actually. It's just for a very small network where you have just few offices, maybe 3, 4, 5, like that. So talking of an enterprise kind of design, it will never do this because it's not a scalable design. When you say scalable, is it a scalability in the sense that as a company expands, more devices are being added. So this is not going to scale, but the client and server architecture will scale better. And that's why you have more of it in most companies these days. And it's also not a secure design for most companies if they want to even do it. Though it doesn't cost much, but it's not there's going to be no way to centrally manage devices even as well. But in the client and server architecture, every devices can be managed from one particular console. Yes. There's a server called Active Directory. That is like the database for all user accounts in most companies. From the Active Directory server, they can lock your account. You will not be able to access your system when it is done. Because it's like a central repository where all user accounts are being managed from. Your system is the client, then the server hosting that Active Directory service is the server. Or the computer hosting that Active Directory service is the server. So that's how it is in this case. Now, talking of end devices, okay, sorry, let me not say end devices. End device is where messages originate from and where it is received. So, like I said earlier, end devices can also be referred to as a host here, right? So, most end devices can be a desktop, a laptop, a mobile phone, a tab. It can even be a desk phone. So long as the device is participating in sending and receiving messages or sending and receiving requests on the network, it's an end device. Do you understand? So this is a LAN, for instance. This is a local area network. This is another local area network. So the end devices here is this guy and this guy. Also here, this desktop and the phones is an end device. We understand. So this is a switch. This is the server in this case. This is the server in this case. So in this case, they are all connecting to the switch here. The switch is not an end device, it's an intermediary device because it's connecting everybody. The data originating from all the end devices are being terminated on the switch. They are in turn relayed to the perimeter device, which is usually a router or a firewall. Right. So that's how it is. So end devices can send and receive messages. Messages originate from them, or requests originate from them. And they also receive requests from other devices, depending on who is sending and who is receiving. These are two different networks, network A and network B. So this person can send maybe a WhatsApp message to this person here, and the person is going to receive it. So long as there's internet. So that's how it is. Now, talking of intermediary devices, intermediary network devices are devices that connect end devices together. Just like we are seeing here, the switch is an intermediary device. It connects this computer together. In some cases, you'll be having the switch connecting to an access point. And the access point will be, the access point will be providing wireless services to end devices. That's why you see some people connecting, they tell you they're connecting via Wi-Fi. So what Wi-Fi does is it's sending electromagnetic signals in form of waves. It sends it to your device. You're able to connect. Your data goes in form of electromagnetic signals back to the access point. So the access point will now relay it to the switch. That is what happens. So now a wireless router is an intermediary device. It provides wireless access and it also routes your data packets to the internet. A LAN switch also relays your data to the router. A router routes your packets to the internet. A firewall is the security device that checks and be sure that malicious traffic does not find their way into your network. We have a multi-layer switch. Multi-layer switch can act as a layer 2 and layer 3 device. That's why they call it multi-layer switch. It's a switch, but it can act as the router too as well. So it performs the function of a switch and also performs some of the functions of a router. So intermediary devices interconnects end devices. And I just mentioned a switch, a wireless access point, a router, and a firewall. So all your traffic flows through these guys that are seen on the screen. All your traffic, your data, your WhatsApp messages, your emails, your whatever that you're sending through the internet flows to these guys. So there's a way they handle each of your data. Can be a voice data, can be a video data, can be the normal data, your normal file data that you share. So they have their way of handling those data. We are going to get into that in the later topics. So basically, they regenerate and retransmit signals. Yes, an access point does that. The switch does that as well. So when the data from your phone or your laptop gets to them, they regenerate it, or they can actually retransmit it. Regenerating in the sense that there's a process called encapsulation that happens when, should I go into that now? We have 7 layers in computer networking. There are 7 layers in networking. So from layer 7 at the top to layer 1, before it goes into the cables that you have, it's the process of moving the data from layer 7 down to 1 is called encapsulation. So this is your device, your laptop, for instance. So when it sends the traffic, it goes from layer 7 to layer 1. This process is called encapsulation. And during that process, regeneration happens. When it gets down, retransmission also happens as well when it gets to layer 3. But the router will retransmit. After checking the pathways, after checking the destination network where you are sending your data to, it will resend it. It checks its log. The router has a log for all the destination networks that you want to send your data to. It checks, and whenever it sees the matching destination, it sends the signal. It sends the data to that destination. Right? So all these routers have their ways of communicating with each other. So what they do is they also notify each other of errors and communication failures. Yes, when an interface is down, they tell themselves. When an interface is down, they tell themselves. When a route or a path is no more available, a route, maybe the shortest path to the destination where the router will forward the traffic to, in order to easily get to the person you are sending your WhatsApp messages to, for instance, or your data to. If the route or the link is down, they will talk to themselves and calculate another path, because there are many paths to destination. So once they notice the link is down, they communicate to other neighboring routers. They tell themselves. And this is possible through routing protocols, dynamic routing protocols, because we have static routes and we have dynamic routes. So we are going to get into that too as well in the later modules. So routers talk to themselves without human intervention. So that happens. So that's about the intermediary network devices. They are the devices that connect end devices to the network. Right? So talking of network media, when you say network media, if this data is being carried by these guys, these intermediary network devices, it has to move through a media. The switch is connecting to an access point that wirelessly provided the wireless or the Wi-Fi signal to you. So once the Wi-Fi signal leaves, once data leaves your system wirelessly to the access point, the access point relays the data to the switch because it has a wired connection. All access points have a wired connection to the switch. So the switch is also having a wired connection to the router. So that wire that you see is not a wire, it's a cable. And it's usually referred to as a network media. So it's a path through which your message travels. So there are now different types of network media. Actually, they are in 2 forms. It can be in wired and in wireless. Wireless in the sense that uses electromagnetic waves that I mentioned earlier. So wired can be in different forms. It can be through copper cables, and it can be through fiber optic cable. It can even be through coaxial. Before now, I don't know. Before now, they used to, I don't know how they were doing this thing when talking or when when data demand was not high, when the bandwidth usage was still very, very minimal. When people were using 1.5 Mbps, 1.5 MB per second, and they were still very okay. Some were using coaxial cables. So, but now you find more of copper cables. So this copper has two forms. There's shielded, this is the shielded type, and this is the unshielded type. They have their properties and their use cases as well. Right. So I don't know if time permits, I'm going to show you guys how to connect the cable and connect to a switch or your router or even your device as well. So this is a fiber optic cable. Fiber optic is the fastest network media on Earth currently. Because it transfers data in the speed of light. It's way, way faster than a copper cable. A copper cable has its use case. In most companies, you see it in their local area network. And there are cases where they use fiber. It has its distance limit of 100 meters. So they are relaying data between two sites that is, farther than 100 meters. Then you have to use a fiber. So this is a wireless router as well. Do you understand? So coppers transfers your data in form of electrical pulses like this. It goes like this. Then that of a fiber optic just goes straight. It transfers data in form of light. So like I said, it's the fastest networking media on Earth. Then for wireless, it uses waves as well. So it uses modulation. So depending on the frequency, there are two types of frequencies in Wi-Fi access. We have the 2.4 gigahertz and we have the 5 gigahertz. 5 gigahertz has the highest speed, but its coverage is not high. 2.1 gigahertz has average speed, but can travel a wider coverage. So we have most legacy devices operating. There are devices that operate on 2.1 gigahertz band. Most devices operate, especially IoT devices, they operate on this band. So as a network engineer, on the back end, you would know how to manage the bands. Because when you have much devices on a particular band, it affects your network. It starts slowing down the network speed. Users start complaining that network is slow. It happens. Right? So that's about network media. They are like the carriage, or should I call them the paths through which, or I should call them a medium, rather. A medium that carries our data between different networks. It carries your data from the PC to your switch, then to your router, then it goes down to your ISP on the cloud, and like that. So it gets to the receiving end. That's how it is. So talking about network representations and topologies. So topology is just a design. When they say topology, don't be confused about the English that they are saying. Representations can be referred to as topologies. The names can be used interchangeably actually, but this is usually used by network engineers. This is used by non-network engineers. When you say topology, an engineer understands. When you say representation, it sounds like a layman kind of thing. So what they are saying. So you can now have two types of topology. One is physical and one is logical. So the reason they call it representation because the people that are not engineers, when presenting a design, a network design to a layman that is not an engineer, presenting physical topology to them will be the best because they will understand it when they see the design. Or if it's a logical topology, you can send it to an engineer, your fellow network engineers, and they will see it and understand what you're talking about. So this will be having the physical demarcations, the title of the office, you see something like account office, HR office, and the lines like that. You see a shelf connecting to like that. So they'll be seeing the offices linking to each other. It's not like that in the logical topology. What you'll be seeing in the logical topology is IP addresses, VLANs, subnets, and their lines like that. The interfaces that you want to use. Yeah, exactly. So let's look at it in detail. Now, talking of topologies, network diagrams, often called topology diagrams, use symbols to represent the devices between the network. So all these devices that are seen here are just images. This is not the way they look in real life. Do you understand? This is not the way they look in real life. In real life, fine, when you see this is looking more like a desktop. It's a desktop computer. This has the image of a laptop. You see, it has a lot of similarities with the way it is in real life. Some don't look like the way they are in real life. Like a firewall, for instance. Look at this. This is not how a firewall looks in real life. But logically, anywhere you see in any network design, when you see this wall design, this one, let me use this. When you see this design, this thing, just know that it's a firewall. Anywhere you see this design that has this circle and like a star on it, you know it's a layer 3 switch. It's a layer 2 switch. It's a router. It's a printer. This is just how they look on most simulation softwares. Simulation softwares are softwares that we use to simulate scenarios, that we use to test. Most times, engineers don't just go online and start, or should I say, go on live devices and start configuring. Most times, you have to test the scenarios to be sure that it works before deploying on real life devices. You understand? So you don't mess things up. So any technology that is to be rolled out that you want to go live in the network has to be tested first using simulation softwares, the likes of Packet Tracer. Packet Tracer is a very, very handy tool. We also have GNS3. GNS3 is also very handy. It's free. You can just download it and start using it. We also have this EVE-NG as well. There's EVE-NG. Those are simulation softwares that you can use. So these are the devices you see. I will open my Packet Tracer for you guys to see. I think I have it here. I can open for you. Okay, it's trying to load now. So it prompts me to sign into my, do I still remember my password? Let me see. This is very problems. I hope I still click. Let me use Google then. This is very problems. If I still remember the password, all right, okay. So it's asking me to verify I'm trying to sign in, and I'll say yes to it. Okay, as you can see, I'm in now. Um, He's already gonna be coming. Okay, so what's happening again? What is this? This is one of the reasons I don't use my packet tracer when I'm connected to the internet. To just keep popping up several. I don't know why they label this. So most times it's advised to just log into your packet tracer offline when you want to use it. See, it's not allowing me to use it. So I just signed in now and it's still messing up. Okay, so let's not allow that to delay us. I'll sign in. This is the other screen while it's nonsense. I just sign in now and it's still. So why is it taking me to this place? It shouldn't. This thing is just something. Okay, I'll show you. I'm going to walk you through how the packages environment is before the end of this. Let's not allow this to delay us. Let me close this and close this as well. Yeah. Okay, let's shut down. Please remind me before the end because I'll show you guys. So now talking of network diagrams, you can see important things that you need to know. The network interface card, yes, or popularly referred to as the NIC card. We have the physical ports and we have an interface. So when you say a port, an interface, a lot of people usually get this wrong most times. They get this, the ports and interface are usually used. They interchange them actually. So a port is an interface. An interface is also a port, but it depends on the use case. For the reason I said that is because you have a layer 3 device. A layer 3 device can be assigned, can operate at layer 3, but a layer 2 device cannot operate at layer 3. Some layer 3 devices can operate at layer 2, but most layer 2 devices cannot operate at layer 3. So the reason is this: on a switch, for instance, if you have this, let me come to this place and say switch ports. Switch ports, looking at this image. So this is what we call, let me see. Can you see these ports that you are seeing here can be referred to as an interface and can also be referred to as a port. So it's a port in the sense that you cannot assign an IP address to it, but you cannot call it a port if an IP address is assigned to it. If it's having an IP, then it's operating at layer 3. So you can't call it a port again. It has become an interface. Take, for instance, a firewall interface, a router interface, and some switch interfaces that are operating at layer 3. If that device, that port, if that port that you're connecting your network cable to is having an IP address, then it is referred to as an interface. If it's not having an IP, if it's just there, like it's just providing layer 2 connectivity, it's not having an IP address, then you can refer to it as a physical port. You're going to get all these things in details in later modules. This is just like an introduction to them. So please try and understand it so you can ask questions when we get to them in later modules. Right. So a topology consists of all these devices: a firewall, a switch, a router, a wireless access point, a desktop, a laptop, everything all together forms what we call a topology. So like I said, let's move to the next slide. I was talking about the physical and logical topology. Now look at this side by side with each other. You can see the physical topology on the left and the logical topology on the right. Look at the physical topologies here. See how detailed it is. This is the server room. You see, this is the server room. So there are web server in there. We have an email server, a file server in there. In the server room, you can see shelf or rack 1 or rack 2, like that. So this is the IT office. It is well detailed. This is room 2124. They have rack 1, rack 2, rack 3. You can see this is the first classroom, second classroom. You can see all these in a logical topology. Physical topology is for a layman, probably when you are doing your presentation to get approvals, you want to send to your MD or something. Those non-technical people that don't understand the technical jargons, they just want to see what they would just have a glance and understand what they're talking about. You can send this to them. So when it comes to logical topology, the illustration is deep. This place, we are not having the IP address in the physical topology. There's no interface ID in the physical topology. There's no network address in the physical topology. Even the device type is not there. Do you understand? So, but in this place, you are going to be seeing where the network that the devices will belong to. The subnet mask could be there. The VLANs, each of these are having different VLANs. So automatically, when you see this, you know this is a trunk link, this is a trunk link, all connecting to the router that is providing routing to the internet. So you are going to know with this picture, you know where a layer 3 device would be, you know where a layer 2 device would be, you know where your host will reside, you are knowing where the server subnet is. Right? You can see it's more, if you look at it, there's a very big difference between both. One is having a detail of the building and just the devices. The other is having a detail of the network and the services that each of the networks will provide with the interfaces that will be connecting to each of it. You can see there's no interface ID here. If you look at this place, there's no interface ID. But there are interface ID in this logical topologies. So you will know where you have fast internet, and you will know where you're going to have reliable internet as well. So these are the difference. Logical is more detailed than physical. Physical is just to show the building structure and where you be having your devices. So logical shows what is going to be configured on those networking devices that will be in the building. So any engineer that sees this now knows what to configure. With just this, he knows how to start. When he sees this, he'll be lost. He'll be like, I need the logical topology. I need to know what I need to configure on each of these devices. Fine, I've seen where the devices will be kept. I can see the classroom, I can see the server room, I can see the IT office. So what are the things that will be configured on them? What are the services that each devices that are going to be in each room should be providing? So you can't get all that except you work with logical topology. So that's it. So talking of common types of networks that we have, so there are different types of network. So there are many of them. I can't say it's 5, I can't say it's 10. There are many of them depending on what you want to do. So what you want, the use case, what you want to achieve is going to determine the kind of network that you're going to use. Right, so we have a small home network. This is just, we can call this a PAN, personal area network, where you have just your TV and your Bluetooth devices connected. You can connect your phone to it and just few gadgets together. It's a small home network. Then we have SOHO. SOHO means small office, home office. This is even common these days for those that are working from home. Right. So we have the medium and large network. This medium and large network is what most companies use these days. It's what we use in most of our offices. And we have the worldwide network. This connects networks together. We can refer to it as an internet. The internet is an abbreviation of inter network. That is network of networks. This is a network. 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 So all of them are connecting to each other. Do you understand? That's how they call it. So internet is just an abbreviation for inter-network. So internet, in simple terms, is a network of networks. Networking networks together is what refers as internet. Why a network is just the connecting of two or more devices within a geographical area. Now, what determines the types of network is two things: the coverage and the number of devices connected. We are still coming to that. Now, so this is about small office, SOHO, medium and large scale networks, then the worldwide networks. Let's go to others to see the types of networks that we have. So we have LAN and we have WAN. This is common. A lot of people know of LAN and WAN, but don't know about other types of networks. So LAN is an acronym for local area network. WAN is also an abbreviation for wide area networks. We've not mentioned internet here, right? So now network infrastructures vary greatly in terms of what? Like I mentioned earlier, the area that you're covering determines the kind of network you're going to use. The number of devices that will be connecting and the kind of services you want the network to be providing also matters. And the area of responsibility, the coverage. These are the four major things that determines the types of networks that we have. So when you say local area network, as the name implies, it means local. It's just within a very small geographical zone, just between offices or between two buildings together. It is not wide, it's just local. When you say wide, it means it has crossed border. Do you understand? It has gone beyond a mini geographical area now. It has gone beyond that. It has gone beyond the city. It has extended to other cities. That's what it means. So this is a LAN. Home office is somebody's local LAN. This is also a corporate LAN. This is a branch local area network. Do you understand? So now it is a LAN because this person is working, is a teleworker, is working from home. So it's just within this place. It's under the person's control. This is also under somebody's control, the head office. This is the branch office, also under somebody's control. So they now have a way of connecting them to the internet. Because this is an ISP, let's say this is MTN, let's say this is Glo, and maybe this is Spectranet. So all the ISPs have their ways of talking to each other. So some services are configured by the admin to route traffic from the central head office to the branch office. That's why you see somebody in Abuja can call somebody in Lagos. Why? Because they have some services running through the ISP network. So they're extending their LAN to this place. They're extending their LAN from central office down to the branch office. That doesn't hit an internet. Doesn't make it a WAN. It's still a LAN because it's managed by the same admin. It's just running some services through the service provider's network down to their branch office. So please let's know the difference. Local area network and wide area networks. So what determines the size and the type is the site, the area of responsibility, the number of services provided, the amount of users or devices that will be connected, and the size as well. So now talking of LAN, okay, it's a continuation. That's good. This is a continuation. Look at this. Local area network infrastructure that spans a small geographical area. This is a wide network infrastructure that spans across a wide geographical area. Branch 1, branch 2, connected to 1. This is like the head office. This is like the branch office. Connected. The network has been extended down to the other branch. So you can interconnect two sites through one. And if you don't want it to be, if it's a small company, very small company, you can have it just located within. It's not all companies that have branch offices around. Some only have one building, and that's a LAN. So those that have their presence in other states, for instance, can extend their network to the service provider network. They can extend the services through the service provider network to the other branch. So the speed cannot be compared with each other in this case. The kind of speed you have in LAN. Somebody missing out.
You can continue now.
Hello. Please confirm if you can hear me.
I can hear you.
Okay. Sorry, I think my internet system was acting up. That's why. You can see my screen, right?
Yes.
Okay. So that's the difference between LAN and WAN. There are different types of networks as well, actually, that we need to know about. There's MAN. MAN, when you say MAN, I'm talking of Metropolitan Area Network. That's MAN, MAN, Metropolitan Area Network. This is spanning across the metropolis. There's PAN. This is a personal area network, just for your personal devices. There's SAN as well. SAN means storage area network. This is a network for storage, for servers that are providing storage as a service on the cloud. There's storage as a service on the cloud. So this is actually a network for the kind of network they use. And then what kind of networks they came. Yes, I think that's okay. There's one. There's WLAN. That's wireless local area network. Yeah, WLAN. Yeah, I think that's all. So let's move to the new slide. Yes, talking of the internet, this is where the game is. Now, when you say internet, a lot of people don't really understand what the internet is. Like I mentioned earlier, I said the internet is the network of network. As the name implies, inter-network. He just shortened it was shortened to internet, but it's actually internetwork. So the internet is a worldwide collection of interconnected LANs and WANs. Do you understand? So LANs are connected to each other using WANs. So if not for the internet, how would it have been possible for you to connect with me? This training would not have been possible. You are connected using your personal area network, maybe a mobile hotspot, for instance. I am connecting using the Wi-Fi I have here. Some people are connecting using their office internet, different ISPs. You are using MTN, some people are using Glo. We are all using our data, and we can communicate and collaborate, irrespective of where we are, irrespective of the kind of ISPs, irrespective of the type of internet that we are using. It will connect with each other. Do you understand? So that's how it is. So ones may use copper wires, they may use fiber optic or cables or wireless transmissions. Most times, the wide area network cable, what is common these days now is that they use fiber, because fiber is the fastest networking media on earth currently. So you would see fiber connection between ones most times. ISPs use fiber connections. And that's why you see most times when your internet is down, MTN will tell you that we are sorry, we're having a fiber cut, probably because there's a road construction somewhere. And the engineers, the civil engineers unknowingly touched the cables. So this happens a lot, right? There used to be copper wires, but I don't think it works again like that. Everybody's moving to fiber now. But there's a new concept called FTTD. No, FTTH, yeah. We call it fiber to the home. So this fiber to the home concept has killed the use of copper wires on one. A lot of people don't use copper wires again. Even residential internet plans, not everybody is using fiber. Do you understand? So you see more wireless transmissions too outside. When you have masts, those big masts, those MTN masts you see, they are providing wireless connectivity to that particular area where they are. So the internet is big. You can see this is their own network. These people they are in their house, they have internet. This is a hospital, they have internet. This is a government office, they have internet. This is a business office, they have internet. This is a school, they have internet. So all the ISPs, MTN, Glo, Airtel, Spectranet, Cobranet, May1, all of them, they have their way of connecting to each other. So because you are connected to them, you can browse the internet. And that's why somebody in his house can be, you'll be hearing the person saying, I'm working from home. You'll be hearing people saying, I'm working remotely. Remote job would not have been possible without the internet. Do you understand? So they have a client software. This person is in his house. So there's a client software that he connects with. This is Office, for instance. This is the Office. So there's a client software he would connect with from his house that will take his traffic back to the office. And it can be accessing resources here on this office. And see sitting right in front of his table. About the internet. Don't let anybody lie to you that the internet is owned by anybody. Even the government does not own it. Is that controls how the internet is used. Do you understand? So there are many of them. We have the IEEE. So those of us that did electrical electronic engineering will know what IEEE is. It's an institute of electrical electronic. They are part of the people that are regulating the internet. We have IETF, this Internet Engineering Task Force. ICANN is Internet Corporation for Assigned Names and Numbers. Yeah. This one is IAB's Internet Architecture Board. All these people are not the owner of the internet, but they have the roles they play in ensuring that the internet is safe for everybody. Do you understand? So, guess the message here. The internet is not owned by anybody. It's not owned by Elon Musk. It's not owned by Facebook. Don't let anybody deceive you. They only own their products. Elon Musk rather only owns X. Mark Zuckerberg only owns Facebook. He cannot own the internet. He owns Facebook, he owns WhatsApp, and whatever services. All his services, all the products that he owns on the internet are using internet technology. In compliance with the regulatory body requirements. From time to time, the IETF will pay visits to his data center. ICANN will go, IEEE, just to ensure that, everything is in line with ensuring a safe internet for all. So that's it about internet. Okay, talking of intranet and extranet. Who have an idea of what this is? Any idea from everybody? Who has heard of internet extranet, and intranet? Anybody? Nobody saying anything now. Hello?
I guess extranet is a private network. I've heard of which are like intranet, extranet. But I know extranet is like a private network.
Okay,
Can you hear me,
so
sir?
the thing is, when you see, yeah, I can. I'm with you. I'm with you. I can hear you.
I've heard of which is like a private network.
Okay, so this is what it is. Let me clarify it for us to understand. When you say internet, when you say internet, see what they wrote here, the word. That means you're talking of the network of networks, like the network connecting the entire world together. That is connecting everybody together in the whole world, be you in Asia or Africa, anywhere. This is the network that connects everybody. You can see it's at the outer layer of the globe. It connects
Yes, sir.
everybody. Now, talking of extranet, extranet is also a part of the intranet. This is, wait, let me talk of this. Internet is owned by the company alone. It's just a kind of access that is limited to people that are working together, staffs of the company, for instance. Take, for instance, GT Bank. I'm using GT Bank as a case study. GT Bank staffs have their intranet. Intranet, when you say intranet, you're talking of a collection, a private network that is only known to the staffs of GT Bank. It's not accessible to somebody that is outside GT Bank. It's not even accessible, it's not accessible to GT Bank customers. I am a GT Bank customer. I have an account with them. Whoever has an account with GT Bank is a GT Bank customer. Do you understand? So I don't have access to that particular portion of their internet, their intranet rather. So it's only staffs of the company that have access to it. The likes of their shared folders, their staff ID, their email servers, their account servers, the servers where they have all accounting information and everything. I don't have access to it because I'm just a customer, only using their bank to put my money, right? So it's an intranet in the sense that it's only accessible to GT Bank staffs. So when they get there, most times in the morning, when they get to the office, they log in with their username and password. Customers don't have the username and password. The username and password that customers have is for a different use case, not to access GT Bank network, not to access GT Bank laptops. You understand? These are only accessed by their staffs. Now, talking of extranet, extranet is a portion of the intranet that is made accessible to the public. Not just the public, not the public. When I say public, not everybody on the internet, but people who are using their service or people that GT Bank is using their service. Take, for instance, we that are having GT Bank accounts. They have a server outside. They have a server inside. That server that is inside is accessible only to their staffs. The server that is outside is providing access to customers outside the network. That's why when you open your mobile app, most times, you open your mobile app, the mobile app is not connecting you to the main server inside GT Bank. It's connecting you, it has your record, right? It's connecting you to the publicly accessible server. the server that is made accessible to the public. So it's an extranet. I don't know if I'm making any, if you are getting me. This is for staffs. This is for customers. This is for everybody. Am I making sense? Intranet is only company users. Extranet is for collaborators, maybe customers, or people that are supplying, that are using GTBank services, or that GTBank is using their service. It's an extranet. You log into it, you see welcome to GTBank, blah, blah, blah. That it's not the main GTBank server. So when you open your mobile app and you're seeing your account balance and everything, this is the server that is responding to you, the one at the extranet, the one facing the public, facing those people that are using GTBank services, not the one inside the company as well. So now the internet is what connects everybody together. Do you understand? So that's the difference between internet, extranet, and intranet. I hope I'm able to clarify that. So talking of the next slide, let's look at internet connections. Yeah. Internet connections. Yes. So there are many ways to connect to the internet, actually. Many ways to connect to the internet. So depending on what you want to do, or the kind of devices that you want to use to connect, we can be using, for instance, now if the requirement for your internet access is just to open web pages, you might feel you need maybe your mobile data to just connect. Just to open, you're not doing anything much, you're not streaming, you're not just you, right? So if it's for business purpose, you have about maybe 50 or 100 users. You cannot be using mobile hotspots to connect. In fact, you can't even be using the normal NTN router to connect because it's the number of users are much. So there's the kind of internet access that you guys need for that. So depending on the number of users and the kind of services that you want to render on the network, that's what determines the kind of internet. So your location too plays a key role in this. There are some locations where you can't take fiber to. You just use radio straight up. And there's some locations where you can't even use anything. You just need a satellite internet. Right? Maybe in a desert or in a remote location where it's very far from the city. So now look at this. The popular services for home users and small office include broadband cable, broadband digital subscriber line. Yes, we have the DSL, so wireless ones and their like that. So mobile services. These mobile services has to do with your hotspots. Then digital subscriber line has been used for a very long time. It's the what is it called? The kind of internet connections that people were using through the phones, the intercoms that were using those days. So those cables were also providing internet access. Right. So we have broadband cable, yes, the use of this 4G lights, 4G and their likes like that, that SpectraNet routers are providing. SpectraNet, NTN router, and their likes. Those are broadband internet access. So they are popular for who? For home users. So talking of organizations that need faster connections to support maybe IP phones, video conferencing, and data center, then if that's the kind of technology you want, then you need a service provider internet access. So most times, most ISPs, they call them ISPs, internet service provider. They provide two types of internet. There is residential and there is enterprise. So the difference is that these residentials, we all know that residentials residential internet requirements is not much. They just want to connect their smart TVs, laptops, and phones. But talking of the enterprise, the use case is different. People are going to be doing meetings, they'll be doing video conference meetings, they will do voice meetings, they will be having some services that will be accessed by people outside the country, maybe the CEO or the MD, like that. A lot of things, a lot of requirements. Maybe they have an app that they are hosting on the server that their customer are using to access their products, a lot of things like that. So this kind of network is complicated. It's not like the residential network that people are used to. You don't just browse. A lot of things are considered in this enterprise network phase. You have security implications of, so everything that you want to do, they will consider security first. They will put in measures in place, physical security, logical security, MFA, last multi-factor authentication, a lot of things like that are considered. So that's what the business class interconnections usually have when the service provider provide internet to them. Their requirements are much, and that's why the cost of residential internet is low. For business or enterprise internet is usually very high. So that's it. Now you can see the types of connections and the kind of services they provide here. So for cable is dedicated, especially when it's a fiber cable. My goodness, you enjoy it. So the bandwidth is high. It's always on. Like it's just connected to, it's connected from the ISP office to your own house or to your office. So nobody's sharing the cable with you. It's just you and your devices. So the internet is always the speed of light, because they are bringing cables from the office down to your house or from the office down to your office. So there's direct connection through the cable to the base station. So, but talking of digital subscriber line, it's also a high bandwidth kind of internet access, but it's not high. It doesn't meet the current day requirements because it uses phone line. Do you understand? Because it uses phone line, so the bandwidth is okay, but it doesn't scale. You can't compare it with a cable. And besides, how many people use this digital subscriber line in Nigeria? In advanced countries, some still use it, but in this, it doesn't scale well because users are, as the company begin to scale and the business is expanding, users are increasing, this is not going to work because why? It's running over a telephone line. So another fast internet is cellular network, which is the one that we use on our phone, using a cell phone network. I'm sure that's what most of us are using to connect our mobile internet. You hotspot your phone and you're connecting to your laptop and you're good. So under this cellular, that's where we have the likes of 1G, 2G, 3G, 4G, 5G. I think 5G is the highest we have now. So we have satellites too. Satellites is the kind of internet access that is used in rural areas or remote location where there's no houses. You don't have any house, you don't have, like, it's a very remote place, mostly in the desert, right? And they need internet access. This is what people in the ship use most times when they're in the middle of the sea. Then we have dial-up telephone. This one too is old. I don't think they use it here in Nigeria anymore. It's a very low cost internet kind of option. People that use, if you know of modem, I don't know if you've heard of internet modem. So what modem means is this. This MO is an acronym for modulation. This DM is an acronym for demodulation. So what modem does is this. It converts your data into voice and sends it to the telephone network. So on the receiving end, He converts it from the telephone, from the voice, he converts it back to data and send it to the user. And that's how the user is able to see it. So that is what happens most times when you're on your mobile data. When you're on your network, you are connected wirelessly. Your data is converted into voice because your SIM is a voice SIM. So the data is sent in form of a voice through MTN network. So when it gets to the receiving end, it demodulates and converts it back to the data that your phone can understand. On the sender's end, it modulates. On the receiver's end, it demodulates. That's what they call it modem, like modulation and demodulation. Don't know if you're getting me. Please signify if you're getting me. Right.
Yes, we are getting you, sir.
Okay. So that's it. Then talking of business internet connections, yeah, of course, business requirements are usually very high. They need high bandwidth, right? Bandwidth requirement is very high. You'll be seeing people using 300 and something MB per second. So they want dedicated connections because customers outside. Imagine if the bank, take for instance, GT Bank's internet goes down, what will happen? Customers will complain. Their mobile app is not opening. This is happening. That is happening. So the internet has to be dedicated. They are using a dedicated internet and it's always on 247. It must not go down. So they have managed services too. Yes, hosted on their network. When you say managed services that are managed requires internet access, like monitoring an internet, for instance, providing security, alert, and their likes like that. So once internet goes down, of course, those services will also go down. So a lot of these resources on the enterprise network are managed remotely. So once the internet goes down, all these things will go down as well. Right. So the kind of internet that business require is an always on kind of internet. That's why most times when ISPs want to provide internet to companies, they'll be talking about what we call SLA. That's what they call SLA, service level agreement. That internet service people want to provide us, what is your uptime? What's your SLA? So most ISPs will tell you that they have 99.9% SLA. That means in a month, the internet will only go down for maybe like 3 hours in a month, which is not possible. Sometimes you see 6 hours downtime, sometimes 7 hours. So most times, the only way to overcome this is to have a backup internet. So most companies have backup internet, and that's why they don't have issues. Right. So we have a dedicated lease line. Yes, this is a lease line that is dedicated to the office. What they have is a cable. They run the cable from the office here down to this place, from the internet office down to the office. So they have Ethernet one. Yes. This Ethernet one is also another thing that they use through fiber. They call it Metro Ethernet. Right? They just use fiber to extend the network from here to here. So they now use a converter in this end to convert it to LAN. They use a converter in this end or to convert it to LAN. We also have the digital subscriber line for business. Yes, that uses symmetric digital subscriber line. This is also a good internet access, but currently we don't use it in this part of the country. Satellite too. I don't think there are any company using satellite in Nigeria. There are companies that are using them, don't get me wrong, but we don't use them on land. It's usually used on the sea or in the desert. In locations where there is no mast, there's no coverage at all, right? So that's where they use satellite kind of internet access. Now, the converging network. Talking of converged network. So before now, in the early days, your data network is different. Your data network is usually on their own. Voice network for intercom usually on their own. Then video network also usually on their own. So these networks, these three different networks operate separately before now, right? You have your intercom voice, which is your voice network. We have your video network, and we have your normal data traffic that you send and receive messages on your devices. So this normal traffic were not in any way together, right? So as technology was advancing, the idea of having a converged network came up. That is, you having just one network, one cable like this, a cable that will carry data for both voice, video, and your regular data traffic. Before now, it used to be different. The regular data traffic is different, voice was different, video was different. So this was costing companies more. But the cost of setting up each of these networks is not small. So with the idea of having a converged network, you can just have just one infrastructure and we'll have all these services, normal regular services, voice service and video service running on just one network. And that was where converged network came into play. See now, we have both data, voice, and video traffic traversing the network. So a lot of things are in place to make this possible. A lot of things were put in place to make this possible. We are going to be discussing that because for a network to have these three different types of network together, it has to be reliable. Reliability in what sense? Video traffic are very sensitive to delays. Voice traffic are very sensitive to delay. This eats up bandwidth. This doesn't eat up bandwidth. This also eats bandwidth as well. So your normal data, you are sending a mail through the same link. Somebody is doing intercom call through the same link. This one is streaming YouTube through the same link. Everybody is doing different things on the same link, right? And everything is going without obstructing each other. You're watching your YouTube, your Netflix, and you're enjoying it. The guy on the call was also doing well. He never complained of latency. He never complained of delays in his call. And the person that is also transferring file is also sending his file without experiencing any slowness in the network. So a lot of things were put in place to make this possible on one network. We are going to be talking about that in the next slide. Right, so let's look at it. Okay, this is about packet tracer. I'm still going to show you guys the packet tracer. Okay, so reliable networks. Don't forget I mentioned to you earlier that for a network to be able to do those things, it has to, have some requirements need to be met before that can be possible. So how is this requirement going to be met? It has to put in place these four things that we are looking at on the screen. One of them is fault tolerance. Fault tolerance in the sense that we have redundancies. When you say redundancy is that you're trying to avoid what we call a single point of failure, where on your network, if one device goes down, right? A device suddenly went down and the entire network is down. That is not a good design. Like just one device on your network goes down and the entire network is down. So a network like that is said to not be fault tolerant. When you say fault tolerance, a fault tolerance network is a network that a device goes down and other devices are still working. Users don't even know that the device went down. It's only the IT people that will know that this device is faulty and we need to change it. It's because it doesn't affect operations. So end users don't want to know. Their own is they just want to be able to browse. They don't want to get anything. So long as they're still able to browse, they don't have issues. So the only way that can be possible is for there to be fault tolerance network. And fault tolerance is only achieved by having redundant devices. You're having two devices. This is going to cost more, but it's the best practice in order to avoid single point of failure. It's the best practice. I'll show you an example of fault tolerance kind of network in the next slide. So now talking of scalability, usually network engineers are supposed to have in mind, they're supposed to have scalability in mind when designing a network. If currently the number of users in your network, the number of users in your company is 15, and you're already designing a network that will accommodate 15 users, you have issues when the business starts to grow. Because over time, business will start expanding and they'll start having new presence in other states. The number of staffs will begin to increase like that. And if the initial design that you have in place is not a scalable design, then you start having issues. So most times when you want to design a network, it is always good to have scalability in mind. Have the picture that in future, that's in future kind of mindset, you are supposed to have it. Do you understand? If you're having that in mind, you are going to be able to build an infrastructure that can accommodate more users. They're talking of quality of service. Yes, quality of service is what helps to achieve this converged network that I mentioned earlier. Quality of service, QoS, is usually configured or it has to be in place if you are using voice and video traffic. Like I said, voice and video are the voice and video traffic are sensitive to delays. Imagine having a video call now and the person is saying hello, hello, like the video is hanging. You can't hear what the person is saying. Do you understand? Because there's no quality of service in place. So quality of service guarantees a dedicated amount of bandwidth to every type of traffic on your network, either voice or data. Let me give you an instance. Take for instance, you're having a bandwidth. This is your internet link. This is your internet link. And your internet access is what? Is let's say 100 Mbps. Mbps means megabits per second. So because you are having voice don't use much of your data. You can give voice, let's say 20 Mbps. You can give your data, let's say 40 Mbps, making 60. And you can give, here we have 40 left. So you can give your video 40 Mbps. So this is for voice, this is for data, and this is for video. So every video traffic, now, video traffic will not, if you're having any voice traffic, for instance, voice traffic will not exceed this place. They will be managing this particular boundary that has been allotted to them. Do you understand? So same thing happens to the normal data traffic. They follow the boundaries that has been allotted to them, as well as video. Videos, because they use more bandwidth. they will also be maintaining this particular boundary that is dedicated to them. Are you getting it? Unlike when you are having with this is what quality of service does. It dedicates a certain amount of bandwidth to a particular type of traffic. Do you understand? So that that particular service will be utilized effectively. There won't be obstructions. But imagine if you're having, for instance, this is how your bandwidth is, and there's no quality of service in place. So data traffic is going like this, voice is also going like this, and your normal regular traffic is like everything will be messed up. Maybe somebody is downloading 10 gig worth of file, or is downloading a video, a seasonal movie. Do you understand? You now start making WhatsApp calls, and there will be issues. The video will be like the user experience when making video or voice calls will be very poor. That's because the quality of service is not in place. So what quality of service does is it guarantees a dedicated amount of traffic to the data types, to the particular type of data that is transversing the network. So that's what it does. Now, the last of them is security. Security is of you can see is appearing at the last. Because after all this discussed, I didn't discuss security. That means we've not discussed anything. You have to put security in place. It's what they call NAC. NAC. NAC means network access control. You have to put access. And the control is a policy that is used to control access to your network. Right? There's what they call MFA2. MFA is used to verify, like more like a second level of verification. If you are proving that you happen to have the username and the password of somebody, then it will pop up another factor to you. There are many factors that uses. You can use who you are, you can use what you know, you can use what you have. Who you are in the sense that your username and password. Then what you have, maybe it can ask you to put your maybe your password. Yeah, what you have, maybe your mobile number or something. Then what you know, maybe your OTP. Yeah. It's one like a second level of authentication. So that's it about fault tolerance. Sorry, quality of security rather. So for a network to be reliable, it has to be able to fulfill these four parameters. If there's fault tolerance on your network and your network is scalable, it has quality of service in place and in security, then the network is reliable. The network is considered to be reliable. Now, we are going to look at this in detail in the next slide so you can understand what I just explained. Now, look at this. Talking of fault tolerance. Talking of fault tolerance, we have two routers. This R1 and this R2. The two routers, one is active, one is backup. So, peradventure, one went down for a reason that is unknown to the network engineer. One just went down. And the internet access switched from this router 1 to router 2. Why? Because they have redundant devices. They have two routers. One is acting as the main, and the other is acting as backup. So if the main goes down, the backup automatically assumes the role of the main. You understand? So in this case, business operations will still continue. Business operations still continue. And it's only the IT person that will know that a device has gone down and will go and fix it. Users will not know. So as opposed to you having a single point of failure where you only have just one device facing the internet, and after the device is down, everybody in the network is not able to access anything. You understand? So fault tolerance helps to limit the impact of failure. Right. So when there's an issue, you can actually take this to the engineer to fix it, while the backup router is still acting up. So that's it. So let's look at this other one, scalability. Now, scalability, like I mentioned earlier, like every network engineer should have this in mind when designing a network. You're designing a network and you're not putting the bigger picture in mind, you will be having issues when the business begins to expand. Look at this. This was the initial design they had in mind. But along the line, the business bought another building and they needed to add up to the existing infrastructure. So they added this one to it. So the number of users now did not affect the existing network infrastructure, right? Because it was built with scalability in mind. So if currently you have 20 users, you design the network that can accommodate 100 users. Currently, there are 20 users. So in the future, as the business begins to expand, we still have 80 additional available users that can join. You get, so that helps. So that really helps to scale up the network. So here they only just have 4 users. Sorry, 3 users added. They can as well add many other users if they want to. Right? So scalability in the sense that new users or new applications or new services are added to the network without impacting or affecting the performance of the existing infrastructure in any way. So that's it. Now, talking of quality of service, I mentioned to you earlier that we are having a converged network. The kind of network we have currently is a converged network. We have an existing infrastructure that supports voice, supports video, and your normal data. So each of them are coexisting in the same infrastructure. So without quality of service, voice, video, and data are likely to impact each other. So what quality of service does is it provides a dedicated amount of bandwidth to each of these services, to the voice service, to the video service, and your data. So without affecting each other. So there's a dedicated amount of bandwidth to voice traffic. You can make your voice calls, you can use your intercom, and it will not be impacted by other services running on the network. Video traffic can also be taking place from time to time without having to impact other devices or other services running on the network. Same happens to data. So if somebody is downloading 200 gig worth of file on that network, because quality of service is in place and has allotted a dedicated amount of bandwidth to voice and video, it's not going to impact them in any way, right? The only bad side is that they can't go beyond the amount of traffic or the amount of bandwidth that has been allotted to them. So it's a very good way to manage. I have a scenario recently where somebody's internet is 20 Mbps. The person is paying a very huge amount of money for this because of the location where he is. And he's not willing to increase his bandwidth to maybe 50 Mbps or 30 Mbps. He said this is what he can afford. And he was proposing that we should look for a way to manage this. On his network, all his users are using Teams. His users are using Teams. They use Teams for meetings every time. Meetings. They use it for video conferencing. Right. On this same network, they have intercoms. They have Avaya intercoms. And on this same network, they have their regular data. They send mails, they receive mails, they do other things, they share files. So how do we put quality of service into place? So what we did in order to help manage the situation, even though the 20 Mbps is very small, is to allot video traffic. We allotted 8 Mbps to video traffic. Then 4 Mbps to voice. The remaining 8 Mbps was given to the normal data. So for whoever that even if everybody is making calls at the same time, they can't use beyond this 4 Mbps. If everybody is making video calls, they can't use beyond this 8 Mbps. And if everybody is transferring data or sending data at the same time, they can't use beyond the 8 Mbps that are allotted to them. So this helps to manage it. If quality of service is not in place, and somebody is downloading the data worth about 1 gig, that's one person can eat up this entire 20 Mbps. And the people that wants to make call, Teams or video calls will not be able to. So that's the advantage of having quality of service. So voice and live video transmissions require higher expectations for those services being delivered. So we allot a particular dedicated amount of bandwidth to them so that they can function effectively. So that's that about quality of service. So let's talk about network security. Security is very paramount, like I mentioned earlier. If there's no security, all these solutions all the how will I put it, the measures that have been put in place will become a mess. Right. So there are different levels of security that needs to be. We have physical security, secure your server room, use access control, maybe fingerprint or anything, right? Because you're using padlock to your server rooms, the padlock can be broken. So use access control. Some use biometric devices, the facial biometrics, some use the thumbprint biometric, depending on whatever it is that the company provides. Just secure the access to your infrastructure. That's for physical security. Talking of logical security, yes, you have a firewall in place. They also have a firewall in place. So the goal of network security is to cover this CIA trade. That's what they call CIA trade. It's a triangle. CIA, confidentiality, integrity, and availability. So if your network is having CIA in place, then you are secure. So what is CIA? Confidentiality in the sense that data that is shared among your staffs is only accessed by the people that the data is shared with. If you're working with GTBank and somebody in HR department sends a mail to you that you are in logistics department, confidentiality is when the person sends the mail successfully. The mail left the person's system and landed on your own system successfully. That means it was intended for you. The mail was sent with you in mind. it was sent to your email address. So he sent it successfully and you receive it successfully. That's confidentiality. So if after sending it, the mail is now intercepted by somebody else before getting to the person that was supposed to receive it, then that's not confidentiality. So when you say something is confidential, that means only people that need to access it are accessing it. That's the first one. Secondly, talking of integrity. Integrity is just a way of assuring that what was sent is what we receive. Because there's a kind of attack called MIT, man in the middle. Yeah, MITM. They call it man in the middle kind of attack. This man in the middle attack is the kind of attack that happens between two people, a sender and a receiver. So the man in the middle attack, what it does is when the sender sends the data, he will receive it, intercept the data. He can copy data to his own device and now relay the data back to the person that it was sent to. So in this case, integrity has not been achieved because it has been intercepted by somebody, an unknown person, a bad guy. So we have to put measures in place to ensure that data that is sent cannot be altered except it gets to the receiver's hand. It cannot be decrypted. So there are technologies that does that too. So the third one is availability. What's the availability? It's just ensuring that what is required is accessible at any time. The people that are supposed to access it. Do you understand? The assurance of timely and reliable access to data for authorized people. What they need to work is accessible to them at that time they need it or at any time they want to use it. Do you understand? That's what security is about. If you want to send something now, it's very important and you are unable to access it, then there's a problem. It's considered as not secure because probably you're in a network and you cannot access a particular resource. It's probably that a DOS attack has been launched or a DDoS attack has been launched. DOS is denial of service attack. It's a kind of attack that denies people, legitimate users, it denies them of access to what they are supposed to have access to. It denies them of it. Do you understand? So for a network to be secure, it has to fulfill these three things: confidentiality, integrity, and availability. And don't forget, physical security has to be in place first before logical security. Logical, this is a part of logical security. There are different network security frameworks that you can adopt into your network and implement them. There's the one called AAA. AAA. That's authentication, authorization, and accounting. This helps in many cases. Authentication verifies who you are. Like, who are you? It answers the question, who are you? Authorization verifies what you should have access to. That's where the idea of least privilege access comes into play. Authorization, what are the things what are the authorized, the files that you're authorized to access? Then accounting verifies what you do. It monitors your time, it checks what you are doing, right? To see if are you trying to access files that are not yours, or are you trying to to go beyond the access that's been given to you, or were you trying to impersonate somebody, right? So this helps. All these are usually logged on the firewalls or the security devices. So that's why when you go to check logs on the network, when you check logs, you see the time somebody signs in and the time he signs out, how many minutes he used, and what he did when he was on the network. So this helps forensic people to gather information when there's an attack, because nobody is to be trusted. In cybersecurity, there's a concept called zero trust. Zero trust. Zero trust stops everything and verifies everything. Even if you're a legitimate user, see, verify yourself first. Let's see. That's what zero trust does. Whether you're a legitimate user or not, whether you're a staff or not, verify yourself. Because nobody is to be trusted. That's about network security. We are going to be stopping here today, and tomorrow we'll continue from network trends. We're going to look at the new trends in computer networking and how we can adopt them to our existing networks. So please feel free to ask your answers, ask your questions, sorry. I'm open to responding to your questions.
Good
I'm
evening,
all
Mr. Nasiru, and
ears.
thank you.
Good evening,
Hello. Good
Mr.
evening.
Yeah, Mr. Shola. Good evening.
Yes, yes. Thank you for this time, and we really enjoyed the training thus far. I would just quickly want to go into the QoS, that quality of service, when you talk about the internet bandwidth sharing. Now, for instance, let's say I have internet of, let's say, 100 Mbps by upload and download. Now, there's this time, over time, this kind of argument that used to come up. Like, what is the quantity of data that I can get, or should I be able to get from that 100 Mbps? Or can you just simplify it for me that, okay, the difference between the speed and quantity of data? So that over time now, because during the course of this training, talk about QoS, that is quality of service, and how those that on video conferencing, voice, and all those things are mapped by the megabyte. Yes, so that it won't cause any form of throttling in the network. I just want to understand this principle, that how this thing works properly.
Okay, thank you. Any other questions? So I can answer everything together. Please feel free to ask your questions. Okay, since there are no questions, let me answer what Mr. Shola just said. Now, let's look at this. Okay, let me use this. So I'll be using your network. I'll be using Bickley's network as an example, so you can get what I'm saying better.
Okay.
This is your network, right? So this is the internet. This is so this is I connect. This I connect is the ISP, for instance. I connect has access to the internet. Now, this is your company. Please mute yourself, please. So this is the company. Let's say company A. Company's network. This company's network. So you have 100 users. When I say 100 users, I'm talking of 100 devices. Some are using phones, some are using laptops, some are using desktops, some are using tabs. Some are, depends, whatever it is that they're using to connect to the network, right? So 100 users, just an assumption. So everybody's connecting. Okay, well, let me put it like this. This is a PC, this is your switch. Switch. Connecting to this PC, the other PC is connecting to this PC. Another PC here, another PC here, like that. So this is your router standing at the perimeter of the network and it's connecting the switch. This router, some people used to have router at the perimeter here. Some at the perimeter, some used to have firewalls. Some companies cannot afford to get a firewall, so they'll just buy a router. Right. So I'm going to explain security that happens in this place. I'm still coming. So here, company here needs internet. They need access to the internet. This is internet. This company here needs access to internet. They will now meet these guys, these iConnect guys, these ISPs that will please, we need access to internet. iConnect will now tell them, we have several plans. We have 100 Mbps, we have 200 Mbps, we have 500. Like, let's go with the least plan, 100 Mbps. You'll be like, okay, it's fine. How do you want it? Do you want it through radio or you want a fiber connection? You'll be like, give us fiber connection. So iConnect having a base station around, they'll bring a fiber, they connect a fiber connection from their office to the company. So this company now, if they want to access internet, the traffic goes from here. It goes like this to iConnect base station, then to the internet. That is what happens. So now when they say 100 Mbps bandwidth, that means if you are testing directly from the edge device, you are going to be getting 100 Mbps. Now, if it gets inside, it won't be 100 Mbps again. 100 Mbps dedicated. When they say dedicated, sometimes they'll tell you 100 Mbps shared. There are times they'll tell you 100 Mbps dedicated. When they say dedicated, it means that your upload and download speed is capped at 100 Mbps. You cannot go beyond 100 Mbps because it's dedicated. If it's shared, if you're using a shared internet, sometimes it will go to 150 because all of you are sharing it. They are like 15 or more customers sharing that internet. Do you understand? So for businesses that are using the internet during the week, you can get a low bandwidth. But during weekends like this, if you are using it, it will be fast because then they've actually closed. They don't work on weekends. Do you understand? So that's a shared kind of internet bandwidth. So in this case, you are getting 100 Mbps bandwidth dedicated. That means we are testing from the link directly from this link. Let me change this thing. If you are testing from this link directly, you get 100 Mbps speed to the internet. Now, the one speed, this is the one speed they're talking about. It's different from LAN speed. The speed inside the LAN is different from the speed outside the LAN. 100 Mbps is a lot on one. Some companies, I know of a company that is paying, that is using 60 Mbps on one, and they are paying about 550 every month, 550,000 for 60 Mbps. And that's someone that is using 20 Mbps and is paying 240. So the way you talk of speed on the one, you don't talk like that. You don't mention it like that in the LAN. In the LAN, we can get 1 gig per second because it's local. It's just few devices connected to each other. You can, this kind of speed you get on the LAN, you can't compare it to the kind of speed you get on the one. Do you understand? So that is about the boundaries they are getting from your ISP. If you want to do direct text, you want to test to be sure that you're getting the required speed. I mentioned SLA earlier. If you want to be sure that you're getting the required speed that you're paying for, you have to connect your device directly to that link. See this cable that is connecting to your firewall, you connect it to your laptop directly and do speed test. You see that you get that particular speed, this particular speed that you're paying for, you get it. So when it connects to this guy and you are at the back and the LAN, you can't get that. You'll be getting roughly 95, 94, 98. You will not get up to this 100 because your device is connecting to a switch. The switch is in turn connecting to the firewall. So if you are doing speed tests, you will not get accurate speed because your traffic is being relayed from the switch to the firewall. You will not get it. So that's about that. So this is about bandwidth from the ISP. Now, the one you mentioned, talking about bandwidth, share, traffic shaping inside. Now, inside your network, because you're using 100 Mbps here, now it's possible that one person here, maybe this guy now, this laptop A inside, now is downloading something of 5 gig, 5 GB per second worth of data. And your internet access is just 100 Mbps. So this guy can eat up the entire 100 Mbps and others network will be slow if he's downloading a very large file. And that is where traffic shaping now comes into play. Inside the LAN, traffic shaping is only relevant inside the LAN. It's not relevant on the one zone. This is the one zone. Outside the network is the one zone. You are controlling the use of internet inside the LAN so that this 100 Mbps that you are paying for will be efficient for you. So how do you do that? We will now put, because this guy is, you don't want to put, even people that are transferring, they are downloading 5 GB worth of file. You want every other users to still be okay. So you can do traffic shaping policy. You can create a traffic shaping policy here on this firewall or on this router that each user should not use more than maybe 5 Mbps at a time. Download and upload. This 5 Mbps is too much. I've been to some places that they just put 1 Mbps per user, depending on how many users they have. Do you understand? So that's how it is. So what I did, like in my company, what we do is we are using more than that. So we have a shared bandwidth for regular users and a shared bandwidth for VIP users. So regular users are using around 30 Mbps and it's shared, we made it shared because you can apply traffic shaping policy to either a user or a group. If you're applying to a user, only that user will be able to, if you're saying 2 Mbps guaranteed bandwidth, 2, they usually write it like this, they'll say 2/2. That means it means 2 upload, 2 download. That's what it means. Do you understand? So if you're having 2 Mbps upload and download, and you're using 100 Mbps. That's an efficient way of managing. The person will not be able to use, even if he's downloading 5 gig or file. It will only take him maybe, it can take him maybe like 7 hours before it will finish downloading. But he will not use more than these 2 Mbps. He can't use more than these 2 MB. So other services can be using the remaining 98 Mbps that you are using out of the 100. Do you understand? So but if there are a group of users, for instance, if there are a group of users, you can have a group and there are like maybe 30 in the group. You just create a policy of maybe 15 Mbps, 15 Mbps, and map it to the group. The entire 30 users will be using this 15 Mbps. All of them cannot be, that's what they'll be contending with. To be shared is a shared policy, is a shared traffic sharing policy for them inside. So we do this most times because we are paying a lot for internet. Internet, the money we pay for internet is very much. Imagine paying for 100 Mbps, if you're using a shared, sorry, if you're using a dedicated bandwidth for 100 Mbps, you're paying roughly, I don't know, for any ISP, you're paying between maybe 350 to 400. So imagine paying this kind of amount every month and people are still complaining that network is slow. You understand? So you have to put traffic sharing policy into play. That for every user connecting to this network in your local network, that's why when you do speed test, you create the policy and you test the policy to be sure that it's working. When you give this people 15 Mbps, maybe accounts, you give them 15 Mbps, IT, maybe 20 Mbps, HR, give them 15. They just share it among themselves. You can do it like that. And you can also create your traffic sharing policy by data type. That you want voice to be maybe 20 Mbps, video to be 20 Mbps, then normal data traffic to maybe 50 Mbps. You can just do something like that. So in this case, you are creating your traffic shaping policy based on the traffic type. So if they're using Teams and the person is making the Teams video call, he falls into voice traffic. Sorry, he falls into video traffic. If he's using Teams to make audio call, it falls into voice traffic. Using Teams to make video call, it falls into video traffic. And this particular bandwidth that has been allotted to that particular traffic type would take pretty sense. And if you are just downloading maybe a movie or you are just downloading a file, you are sending a mail, it falls into the normal data traffic. So the firewall or the perimeter device has its way of categorizing all traffic. So when you have this policy in place, it helps you to manage your internet access. So users will not be complaining that network is slow and network is not slow like that. So that's it. I hope you understood this explanation.
Yes, thank you.
You're welcome. Any other question? My Oga, are you there? Mr. Kunle? Okay, I guess it's a way. So, but it's fine. So we are stopping here. We are stopping right here for today, and we would continue from network trends tomorrow by the grace of God. So we are going to be looking at network trends, the recent, inventions that has emerged in the networking space. You know, so we are going to look at that tomorrow. Then, there are still many topics to look at. Why, how collaboration happens, video communication. Okay, these are the from video communication solutions. We have the WebEx. WebEx is for everybody we only know of Teams and Zoom. WebEx is also another crazy video conferencing solution. Right. So we are going to talk about cloud as well. Class computing types, and some kind of networking technologies that you've not heard of. Yeah, we'll talk about it tomorrow. So thank you. Thanks for your time today, and have a wonderful night rest.
Thank you, sir. We really appreciate it.
All right, you're welcome. Good night.
Thank you, sir.
Good night.
Yeah, good night.